Okay, leading and lagging from the sinusoidal waveform. Okay. All right. Oops. Okay. So we're gonna learn before the general format of sinusoidal waveform is V over T is with the peak value sine omega t plus theta. Okay. It was also with a P sine 2 pi f t plus theta. Okay. It's more sharp here. All right, so that was the peak voltage. Okay. Theta phase shift. Okay. And the omega is the angular frequency we can be writing for the 2 pi f. The f is the frequency, right? All right. So of course the f is 1 over t. T is the period, sometime cycle, the second. Okay. Sometime microsecond, sometime the millisecond here. Okay. All right. So yeah, definitely. I over t. I'm gonna move in here. Okay. I over t definitely same thing. The current sine omega t plus the theta. Okay. So maybe any sinusoidal waveform we can make a format, the official format like this one, V over T and up to I over T here. Okay. So now we're gonna drawing for the reference to graph here. Okay, like this one. All right. So the ARPA sometime radian, sometime the degree here. Okay. The meridian is pi to pi, for example. That is the 180 degree, sometimes 600, maybe 80 degree. Sometime that was the time. Okay. It depends, maybe it depends. So now 0. All right. So now that is the peak voltage. That's right there. And that was the 2 pi. That was the pi here, right? Sometime the degree here, 180 degree. That was 360 degree here. So from here, we're going to see that starting point is the 0, right? And then that was the t here, okay? The 1 period. So that was the, we can, make a formulas like V of t, V sub p, sine 2 pi f plus 0, y0. Usually that case is for the reference sign, so the signal here, starting point to the 0, okay? But, for example, the frequency is like 30, okay, not 30, it's like the 20, for example, the 20 hertz, 1 over the 20 hertz, 0.05 second, okay? Right. So for this case, okay, the same graph means they have the same period, same frequency, because to compare the leading or lagging to describe for the sinusoidal waveform, we have the same frequency, same period. Okay, like this one. For example, the 30-degree here. Okay. So that was 100, maybe 80 minus 30-degree here, 150. And that one is what? 360 minus the 30-degree, 300, the 30-degree here. Okay. And then the peak voltage is the same. The period is the same. Okay. 0.05 second. Okay. It's right there. All right. So this is the reference. This is case one. All right. For this case one, go to the left. Shift go to the left. The 30-degree from the reference one. The reference one, the 0, right? But the for here, go to the left. Means they arrive earlier. I'm gonna the drawing here. Okay. It's right there. So the case one, the graph arrive earlier than to the reference one here, right? So means that graph, for example, that is the graph v sub 2 of t. That was v sub 1 of t. So we're gonna, we're gonna writing here. We're gonna tell v2 of t is leading by v1 of t, the 30-degree. Okay. Okay. This is the v sub 1 of t. So we can make definitions about phase relationship to sinusoidal waveform. V sub the 2 over t is the leading v sub 1 over t by the 30-degree. Why? Because the v sub 2 over t, the earlier than the reference one. That's like this one here. Okay. So the v sub 2 over t, v sub p sine omega t, that is for minus the 30, right? Okay. So that was plus the 30, okay? So that is the alpha. So maybe alpha plus the 30 is going to 0, alpha minus the 30. Okay. So minus the 30 means from the 0, the graph that go to the left. Okay. This is reference. This is the case one. The case one is the leading case. Okay. So what is the leading case? I'm going to show you. Like this one. Okay. So like this one, that is the go to the right. 30-degree here. Okay. So for this case is shift, go to the right, right? This is maybe ARPA. Same thing. That is the base of P. That is the 90 degree, 100, maybe 80 degree, plus 30 degree, plus the 30 degree. That is the 360 degree plus the 30 degree here. Okay. 200 degree, that was 103 degree. Okay. So for this case, the case 2, what we're going to call as V sub 3 of T is lagging. Okay. V1 of T by 30 degree. So they can rewriting here with a P sine omega T plus a minus, sorry, minus 30 degree. Why? Because the alpha is the omega T. The alpha minus 30 degree is going to 0 to find shift. So alpha is equal to the 30 degree, means the plus the 30 degree. So that means, okay, is right one. Okay. So from the reference one, they going to lie the later. Okay. So this is why we sub 3 over T here is lagging v sub 1 over T by the 30 degrees. So maybe any sinusoidal waveform, we can express of the general format, okay? The peak voltage sine omega T plus the theta, okay? It depends on the shift. The plus theta, sometimes the minus theta. The plus theta is for the leading, okay? Minus theta is the lagging. Theta is the 0. That is usually the reference one. Okay. So now we will learn about the last concept one here. Let's say phase relationship of, oops, sorry about that, of sinusoidal, the waveform, okay? So how does delta theta relate to shift in time domain, the delta t? Okay, so usually the time shift, the delta t is proportional to phase shift for one period. Okay, so maybe as I said before in the graph, sometimes the t second, sometimes the alpha, the phase, sometimes the radian, sometimes a degree, okay? We can draw the graph, any sinusoidal waveform in the x-axis, t or alpha. It depends on t and alpha. We have to find the leading, lagging, leading or lagging, sometime delta t, sometime delta theta. So to find this one, we have to know about the really basic important the concept. So delta t over t is equal to theta 360 degrees. That is very important concept. Okay. Any questions?